Okay, so we're given that tangent x equals 3. And then we're told x terminates in quadrant 1. That's actually where you want to start these problems. So quadrant 1, oh, that's not deep enough. Let's try that one. Quadrant 1 is this quadrant here, right? So x terminates, that means the angle looks something like this, right? Because this is the initial side, this is the terminal side, and then we draw a right triangle because we're dealing with right angled trigonometry. Okay, so tangent x is 3 over 1. So here's our angle x that we don't know, but we know that the opposite over the adjacent should be 3 over 1. So that means this could be 3 over 1 here. Opposite could be 3, adjacent could be 1. It could be 6 over 2. There are some options. Let's see. Let's start with this, okay? Because the ratio is going to be the same. I don't think it's going to impact us if we, if we try to think of like 6 over 2. Could be 9 and 3. Right, because 9 over 3 makes 3, yeah. Okay. So any one of those work just as long as the tangent ratio, the opposite over the adjacent, equals 3. So, yeah, I think you could go with 6 over 2 or 9 over 3. You're going to get the same answer. So now that we have that, now that we've gotten two sides, we can find the third side, our c, in the Pythagorean theorem, by doing a squared plus b squared equals c squared. So we got, 3 squared is 9. So we're going to get c is the square root of 10. And now we have enough to say what sine, cosine is, etc. So let's start with sine of 2x. Sine of 2x equals 2 sine x cosine x. So sine of x of this triangle is the opposite over the hypotenuse, right? So sine of x is 3 over the square root of 10, or if we rationalize the denominator, that's 3 square roots of 10 over 10. Okay, and then cosine of x, that's the adjacent to angle x, divided by the hypotenuse. So the adjacent is 1, the hypotenuse is still square root of 10, but if we rationalize the denominator, multiply the top and the bottom by square root of 10, we get this. Now you have enough information to find out what sine of 2x is. You just have to plug it in, okay? Sine of x, we just found out, was 3 square roots of 10 over 10. And then cosine of x was square root of 10 over 10. So if we multiply straight across the numerators, you got 2 times 3 makes 6. Square root of 10 times square root of 10 makes 10. And then straight across the denominator, we get 100. But if you simplify, that's 60 over 100, which makes 6 over 10, which we can simplify a little bit more. That's 3 over 5 for sine of 2x. Okay, and then you can keep going for cosine of 2x. Get rid of this. Yeah, cosine of 2x, use any one of these formulas. They all should come out to the same result because cosine of 2x could equal any of these three things. Okay, so cosine squared, that means we got square root of 10 over 10 squared. And then sine of x squared, that would be 3 square roots of 10 over 10 squared. So if we square the top and the bottom, that's 10 over 100. And then this is going to be 9 times 10 over 100 when we square the top and the bottom. So we get 10 subtracted by 90. That's negative 80. There's days when the mental arithmetic comes easy, and there's days when it does not. So this is negative 4 over 5. And then tangent 2x, using this formula here, it's a pretty straightforward calculation. Tangent x is 3, so 2 times 3 makes 6. And then tangent x is still 3, so 3 squared makes 9. So we get 6 over negative 8, which is, when you simplify 6 over negative 8, that's negative 3 over 4, right?